So in this video, we're going to talk about the area of a triangle. You guys know how to find the area of a triangle, but the area K of a triangle is K equal to 1/2 the base times the height, where B is the base and H is the altitude drawn to the base. Okay. So a little proof for you. So look at a triangle. So say you've got this triangle. And it's got some altitude perpendicular here from the highest point down to the base B. Okay. Around the triangle, let's construct a rectangle like this, rectangle, with a height H and a base B. Now triangle, let's label these areas. So we can call this area 1, area 2, area 3, and area 4. So triangles 1 and 2 are equal in area. So if you think about it, this square looking thing, that rectangle, those are equal area. And triangles 3 and 4, those have equal areas as well. Okay, consequently, the area of the triangle with base B and altitude H is exactly half the area of the rectangle. So the area of the rectangle is BH, so exactly half of that is 1/2 BH. Okay? So kind of rinky-dink, but it's not that difficult. Area of a triangle, 1/2 base times height. Now, find the area of a triangle. A little more interesting. Of a SAS triangle, side angle side triangle. Okay, so say I know. Okay, say I know some angle C, and I know that this side is B and this side is A here. Now I can find the area of the triangle. If the base B and the altitude H are known, then the area is just 1/2 BH, right? That's the area. K equals 1/2 BH. Now how would we get the H? Well, the sine of the angle, sine of C, is equal to opposite over hypotenuse. So H over A. So that tells me that the height, the altitude, is A times the sine of angle C. Okay? Therefore, this formula becomes 1/2 the base times A times the sine of angle C. So 1/2 AB sine of C. So that's a formula. Area equals 1/2 AB sine of angle C. Okay? You could also have 1/2 BC sine of angle A. And you could have 1/2 AC sine of angle B. Okay, so those are the different ways you could do it. All right, dropping altitudes from the other two vertices leads to these other two here. Now it's easiest to remember these following formulas from the wording. So here's a theorem. The area K of a triangle equals 1/2 the product of 2 of the sides times the sine of their included angle. Okay. All right, so let's do an application of this. So find the area K of the triangle for which A equals 8, B equals 6, and C equals 30 degrees. Okay, so what does that look like? So we've got some triangle where we've got A, B, C. And so this is angle A, this is angle B, and this is angle C. And what are we told? We're told for A and B and angle C. So that's SAS. So this is equal to 30 degrees, 6, and 8. So I want to find the area here. So the area is equal to 1/2 AB sine of C, which is equal to 1/2 8 times 6 times the sine of 30 degrees. So 1/2 times 8 times 6 times sine of 30 is 1/2. So what is that, 12? 12 square units. All right, 12 square units. That's the area of that triangle. Now, there's another formula for area of a triangle. It's a theorem called Heron's Formula. So Heron's Formula, it's a triangle with sides little a, little b, little c. Then the area is equal to the square root of s times s minus a times s minus b times s minus c, where s equals 1/2 of all the sides added together. Okay? So if you're given a side, and you want the area of the triangle, so if you're given a triangle with sides 4, 5, and 7, then I'm going to let A equal 4, B equal 5, and C equal 7. Then S is equal to 1/2, 4 plus 5 plus 7. So that means S is equal to 9 and 7 is 16 divided by 2. That's 8. So my formula, K, the area, is 8 times 8 minus 4 times 8 minus 5 times 8 minus 7. So this is equal to 8 times 4 times 3 times 1. Oh goodness, 12, 4 and 3 is 12 times 8, that's 96. So square root 96 is equal to 4 square root 6 simplified, and that's square units. Okay. No biggie going on there. Now, there is a proof in the textbook on Heron's formula. If you want to take a look at that, that's fine with me.